Okay, hi everyone. Until a few minutes ago I thought I had 10 minutes, so I'm going to go through really high compression ratios here. We'll put an uncompressed version up on our website if you want to have a look. So my talk's on basically on cloud databases. Just to introduce Quest real quick, we're a systems management vendor. We're in all sorts of spaces, databases, applications and so forth. Our best known product is probably Toad, which is an IDE for database development. We've had lots of fun with Toad over the years. This is the Star Trek Toad, Haight-Ashbury Toad. But we've got millions of commercial users who are very happy with the product, and we've got probably a couple of million of people who are not paying for it. And in fact, to put that in perspective, if you think about the very first computer programmer, Ada Lovelace, who programmed for Babbage's analytic engine, yes, even she was a Toad. Okay, so you'd think that we're like a database company, we're probably sort of scared of cloud databases and NoSQL, but actually even we can see that the relational database is really cutting it. And you can see it in everyday life in things like Twitter. You know, if you've used Twitter for a long time, you know that you get a fail whale if Twitter can't process your tweet. That's often a database issue. Fail whales become a bit of a cultural icon. Fail whale posters, fail whale children's wear, fail whale ale. And I'm actually going to get a fail whale tattooed on the forehead to explain why I freeze up so often. So what's going on with places like Twitter? They're really pushing the relational database faster or further than it can really go. So if you think about the old way, have a web server, application server, database server, scale out the web servers, database server starts to become a bottleneck. We might add caching, memcache servers. Maybe that's not enough, so we do some replication and add read-only slaves. That's not enough, so we start sharding the database. And at this point, you can sort of see all the patterns between the application and the back end. And this is like a database on crack. And it no longer really has any of the relational database features. You can't do joins, you can't do transactions. You don't really have the transactional consistency that you're supposed to get. And so it's pretty obvious that something's got to give. And CAP theorem, or Brewer's theorem, tells us that you can't have consistency, availability and partition tolerance all in the same product. So where the relational database probably tries to give us consistency, the NoSQL movement and the cloud databases are trying to go for availability and scalability, but maybe with less consistency. So we see a bunch of databases. They generally don't support SQL, they generally don't support atomic transactions, and they generally don't support exact strong consistency, but they generally are very scalable, they're redundant, and they usually have this thing called eventual consistency. When the music stops, all the updates eventually go through. So there's a lot of them. They generally follow a couple of families. There's the key value stores, especially those based on Amazon Dynamo, those based on Google Bigtable, those based on DocumentDB, sort of the ancestors of Lotus Notes, and graph databases to try and have relationships rather than entities. And there's a bunch of them that follow on. And they all sort of fit. There's a number of ways to categorise them. They fit into these families fairly neatly. So we're not sure which ones of these are going to be the big ones in 5 years, but we do believe that it's a legitimate, that they serve a legitimate need. But there's one enterprise need that's not served very well, and this has been best articulated by this comic that was at browsertoolkit.com. You might have seen it. Bob says, how do I query the database? His friend says it's not a database, it's a key value store. Okay, it's a key value store, how do I query it? You write a distributed MapReduce function in Erlang. Did you just tell me to go crack myself? I believe I did, Bob. So that's the problem with Bob. He's not programmed, so he can't query the database. So at Quest, what we're doing in the cloud at the moment is a product we've just released, Toad for cloud databases. And the way it works is basically we've got a Toad client. You can use SQL statements. We can route them to relational databases. We can also translate them to non-SQL databases. We can put that hub in the cloud itself so that you don't have to move the data in and out of the cloud. And that lets us do interesting things like copy data out of a relational database into a NoSQL, or do joins across databases so that you can join from your relational database to your NoSQL database. And here's a screenshot of it. It's joining data in HBase here. You don't need to know SQL, but you can write your own SQL, and it's just drag and drop, and it will issue the query and return the data. How did I do on time?
That's impressive. You're right at 5 minutes.
I timed it exactly 10, and so I don't know. I hope some of that got through.
Give them the URL, Bob.
Yeah, there you go. ToadForCloud.com. Yeah, thanks a lot.
It's really easy, right there. Thank you very much.